continuing with our AI theme, I'd like to invite Alex back up to the stage to talk about what they do at Baseline and share a little bit more about their cooperative business model.
Well, I'll keep introductions short. The crowd seems very similar to a few minutes ago. Alexandre Dubé-Côté. I'm with Baseline, and we're going to be talking about a specific project today, namely one which we've done, we're working on in partnership with Geauthentic. Geauthentic is a solution provider for tracking and remotely operating motor vehicles, particularly in a mining context. They're working on hardware so as to set up dumb vehicles, as it is, and software to have an overview and being able to operate, understand what's going on the field. Ourselves as Baseline, we're providing the AI expertise. So basically, we particularly enjoy working on solution in co-development, particularly with solution providers, for instance, that want specific design capabilities for AI and don't have them internally. That's one of the spots where we shine particularly. And we've been very lucky to have, as mining partners on that project, ArcelorMittal and Rio Tinto, so being able to work on real live data, as well as being able to do on-site testing. Now, I'm going to be theoretical for a very brief moment here, but kind of explain the mind frame in which we approach the project. Basically, looking at the different levels of impact for strategic, tactical, and operational decision-making. Obviously, looking at cascading way starting from strategic decision is a very valid one, but we also find that there's quite a bit of value starting from a bottom-up approach, looking at operational problems and seeing how solving, optimizing can help climb up that ladder and basically optimize. In that case, we're talking about fleet management. So basically, the daily operations of a fleet being more efficient should help build towards tactical decision that is not needing to build as large a fleet to service the same operations. So the specific challenges that both brought us there and were kind of forefront in mind there. We've talked a couple of times about silos already, but what we've observed is that on most operations, it's not a single fleet of light vehicles. It's more likely multiple different small sub-fleets for each department that are not working together. The complexity of planning, Janice mentioned a bit earlier on with Lego blocks, the number of possible arrangements you can find. Well, if you have 10 vehicles and need to visit 100 maintenance sites, the possible ways of going about it are more numerous than the atoms in the universe. So obviously not a human scale to find and figure out the optimal solution to it. And well, last but never least, costs. There's going to be always large posts of expenses, but here we're looking, if only at the maintenance for light vehicles, we're talking about $100,000 a year per vehicle. That's not accounting for the purchase, that's not accounting for the admin support of it, the fuel, obviously, and basically any reduction in the size of the fleet, any reduction in the intensity of its use while serving the same operation is something that can be quite cost benefit. So the actual solution, well, what we strove for, I really like this one, basically quite simple. Bring the right resource, be that a vehicle, a piece of equipment, or a person, to the right location, the different sites on a mining site, at the right moment, keeping in track the various blocking factors that may be at play, and maybe most importantly, doing so as efficiently as possible, using as little resources as possible, and doing so in a way that is optimal for all parties involved. So those two images might look quite similar, but they are functionally very different. One of the first starting point, if you're going to be optimizing movement in any given location, is to have a clear understanding of the lay of the land. If you're talking about off-road mining sites, you do not have the luxury of having Google Maps being able to say, I'm going from point A, I'm headed to point B, what's my travel time, and what's my optimal route. On the left-hand side is a large number of observations of vehicle being at a specific place, traveling a specific speed at a specific direction. That is basically unusable for planning, but part of our project was to build a map representation where you can start navigating from point A to point B and then D and C. From that map. So basically creating usable maps from disparate points. Now, on the other side of the equation, the requirements for any given day for what that fleet needs to accomplish. Now, there's a couple of things that need to be kept in mind. The resources that you have, the number of different vehicles, their capacity, their cost of operation, their current availability, and so on. But obviously, the list of tasks that need to be accomplished, the different profiles of moving people, equipment from one spot to another. I'm listing a couple of different constraints here. The time horizon, so obviously, what's the latest you can arrive with a piece of equipment to a specific spot? How high of a priority is it that gets accomplished in the way specified, the details of what's to be carried. You're thinking about the weight of material, you're thinking about the size of material sometimes. And once again, the sequencing. If you have multiple drop-offs for a single vehicle, then the order in which you're traveling is important. Basically, building a system that keeps all that in mind, but not only that, but is also highly customizable. The idea here is not to find a solution for one given mine site, is to be able to find optimization solution that can take different constraints, different parameters for the vehicles serving them, and still being able to solve. So on your right-hand side is an interface example of how to put in those tasks, as it were. Now, the result here is a sequenced travel path for each vehicle that you've allocated. The idea here is to be able to find something that's never exactly on, but very, very close to the optimal solution for your problem, and keeping in mind a number of different constraints. So that job of planning and allocating that would tend to be done in a more ad hoc manner by fleet managers, you're able to find a solution that is clean and that doesn't take their time to create. It doesn't take their time to make that planning. It takes human intervention into validating, correcting. So instead of building those schedules, they're able to do the sanity check that a good manager is able to do, and using those as efficiently as possible. Now, implementation and impact. Well, we're just about to start in situ deployment of that solution. We've had very, very encouraging results by preliminary testing and simulation, where for the same level of distribution, for the same level of work to be done, for the same number of tasks allocated, we're looking at minus 30% in distance covered. So getting all the same equipment to the same locations, reducing that travel distance. Coincidentally, the effect is the same on fleet size, basically looking at the existing fleets, not only the existing fleets, but the fleets that are used to serve those scenarios, and what's possible to do. We're talking about reductions of roughly 30%. Obviously, those two combined kind of bring together a wealth of cost reductions. We're talking about fuel, we're talking about maintenance costs, we're talking about acquisition and upkeep of different vehicles. but also keeping in mind that there's quite a bit of efficiency there. There's emissions that you're going to be reducing. There's critical time for the people doing the traveling that's going to be allocated to actually mining. So quite interesting on the quantitative side, but on the qualitative side, there's also some interesting points. Basically, improved decision making. You're talking about something that's explainable. You're talking about schedules that make sense and keep in mind the various different constraints that you have, but also you're able to have a bird's eye view that integrates the needs for different sub-fleet managers, as it were. Finally, and once again, last but not least, a pleasant surprise, full honesty, not something design, which was the center of the design, but we've realized that the constraint optimization approach also helped reduce a lot of barriers for EV implementation. Basically, the time to charge, the possible travel distances are all things that can be taken into account. So it by no means destroys and makes small work of the infrastructure's need and so on, but it does reduce some of the friction point of bringing in progressively and then more and more EVs into their light fleets. Now, the results we've had on this have been pleasant enough that we're taking on another project with the same partner, Geauthentic, for another product in development, this time with more of a maintenance planning approach. Quite a few differences in the two problems, but also similarities in the optimization requirements. And we're lucky enough to be working with Canadian royalties on this one. So exciting stuff we hope to be bringing and we hope to be discussing with you in the near future. That's it for me. Now, if you do want to discuss either the solution itself or the various implications or prospect of integrating AI into either a product or a solution, I will be happy to chat with you. Thank you very much.